Einstein's most famous equation, E equals mc², carries one of the biggest myths in physics, relativistic mass. For decades, people believed that going faster makes an object gain mass. Einstein rejected this concept in 1948, yet the myth survives, fueled by misreadings, especially attempts to equate Einstein's equation with the classical kinetic energy law. In this video, the myth is dismantled, from the macroscopic to the subatomic scale of quantum physics. Let's begin with what Einstein's equation actually tells us. Mass-energy equivalence goes far beyond nuclear bombs or the fusion powering the sun. It applies to every energy process in the universe: heating and cooling, charging a battery, compressing a spring, nuclear binding, even light trapped inside a box. In each case, the energy contained within a system contributes directly to its mass, the one all observers agree on. Consider a simple example. Heat any object and its thermal energy, the microscopic fluctuations of its atoms, adds to its mass. Cool it, and the opposite happens. A tiny fraction of mass is lost along with the escaping energy. These changes are real but vanishingly small, detectable only with the most sensitive instruments. Here lies the root of the confusion. Because E equals mc² links energy and mass, many assume that giving an object kinetic energy, speeding it up close to the speed of light, one of the most misunderstood ideas in physics, must also increase its mass. This is the trap. They confuse the invisible statistical fluctuations of particles inside matter, which really do add to rest mass, with the motion of the object as a whole, which does not change its mass. It looks the same in words, but physically it's completely different. But there is a crucial distinction. The kinetic energy of particles within an object counts as internal energy and adds to mass, while the kinetic energy of the object's overall motion is relative to the observer and never changes its mass. One observer sees the object moving, another sees themselves as the one in motion. Some even confuse Einstein's equation with the classical kinetic energy formula, wrongly treating them as the same thing. Kinetic energy depends on motion and the observer, while E equals mc² is deeper. It's the rest energy, the energy bound into mass itself, fixed for fundamental particles, and for systems, the total mass only changes when energy is added or removed. And here's the final nail in the coffin. Equating Einstein's mass-energy equivalence with classical kinetic energy is absurd. Cancel the mass, and you end up with c² equals 1/2 v². Nonsense, because c is a universal constant, while v is just speed. Rest energy is enormous, even at zero velocity, while kinetic energy vanishes at rest, and nuclear physics proves it beyond doubt. Stars, reactors, and bombs release energy exactly as Einstein's equation predicts. If mass truly changed with speed, then it would no longer be an intrinsic property of matter, but an illusion varying from observer to observer. And worse, it would mean every observer lives in a different universe, with a different space-time stitched to their motion, a direct contradiction of Einstein's relativity. That's why physicists abandoned the relativistic mass idea. It blurs the sharp line between internal energy, which belongs to the object, and external motion, which belongs to the observer. Today, it is remembered as one of the biggest E equals mc² misconceptions ever taught in physics education. Relativity resolves this by defining mass as invariant in motion. For composite systems, only internal energy, like heat or binding energy, changes the total mass, never external motion. And when objects speed up, what grows is not mass, but energy and momentum, quantities that together ensure the laws of physics remain consistent across all frames of reference, exactly as Einstein's equation explained. Gravity in Einstein's relativity reinforces the point. It depends not just on mass, but on the entire energy-momentum content of matter. If relativistic mass were real, gravity itself would fracture into contradictions between frames. At the subatomic scale, each type of fundamental particle has a definite invariant mass, a fixed identity. Without this fixed mass identity, atoms would not hold together, chemistry would collapse, and the entire universe would fall into chaos. Electrons, for example, gain energy and momentum when they absorb photons and lose energy when they emit them, yet their own mass never changes. What does change is the total mass of the atom or the larger system they are part of, because binding or released energy is reflected in that system's mass exactly as E equals mc² predicts. All of this leads to one simple truth. Internal energy can change mass, but motion never does. Relativistic mass was once a convenient teaching shortcut, but today it stands as one of the most misleading relics of physics. So, the next time it is claimed that mass grows with speed, remember, the truth is far more shocking and far more beautiful.